So we've all used online translators, and at some point we've probably wondered, how do we know that what it's outputting is correct? Especially when we don't understand the language that we're translating to or from. We might wonder, is this faithfully preserving the meaning of our text? And this is especially true, given that these translating services might have bugs or they might have implicit biases. But unfortunately, what I regret to inform you today is that our work is on how these services may be intentionally and even sometimes silently manipulating your text according to a political agenda. So 4 of the services that we looked at are Chinese operated, and they're accessible in China. Most of their user base is inside of China, but as you can see, they actually have around 10% of their user base outside of China as well. We also looked at Microsoft Bing's Translate. This is also accessible in China. It's the only non-Chinese translator service that we looked at. It's, to our knowledge, only censoring in China, and it's not censoring elsewhere. And the reason why we don't see other ones like Google Translate on this slide is because those are blocked in China for not implementing Chinese censorship. So in this slide, or in this talk, we'll be modeling censorship rules according to what you see here on the slide. Something called an ordered keyword combination. So what this means is that these keywords have to appear in the text in a certain order, all of them, although not necessarily adjacently. And if that's true, then the text gets censored. So this model covers like different types of censorship rules that might be actually implemented in practice, sort of trivially an ordered censored keyword combination system, but this also of course covers singleton keywords. It covers the way that you would be commonly writing regular expressions. It also covers unordered keyword combination rules too, by the use of multiple ordered rules. And the nomenclature that we'll use is just what you see here at the bottom of the slide, these red keywords separated by plus signs. So we have an algorithm that we use to automatically infer these. I won't have time to get into exactly how it works, but I did want to at least walk you through an example, just so that I can provide some intuition. So suppose you have a source sentence like, President Xi Jinping gave a good speech today despite the bad weather, and that there's a keyword combination censoring this, Xi plus Jinping plus bad. So for now, we'll assume that we have some sort of censorship oracle that tells us like whether the text is censored or not. And in this slide, in this talk, we'll be representing that with a green check mark if it's not censored and a red check mark if it is. So the first thing that we'll want to know is just, is this sentence censored at all? And so when we test that, we find that it is, because of course it contains the keywords in the order that the rule requires. Next thing we want to do is find one of the keywords in this keyword combination rule. So we do some binary search to find the end of it. And then we do a linear search just because it's simpler and it's typically as fast, if not sometimes even faster, than doing a one-sided binary search to find the beginning of that keyword. So once we found that, we have to test, is this what's triggering the censorship? Are we done searching yet? In this case, no, we have to still keep going. So we repeat the process. We find the end, we find the beginning, and note too, we have the one that we previously found kind of attached to the end. But unfortunately, this still isn't the complete rule, so we do it once more. Find the end, find the beginning, but this time, hooray, we did it, we found the complete rule, because this is enough to finally trigger censorship. So you can see from this how we started with a sentence, and we were able to automatically infer the rule that was triggering its censorship. Now, compared to, you've probably seen before, either in research or just sort of more colloquially, people testing for censorship just by testing single keywords at a time. and then measuring whether or not they're censored. Um, Compared to what I just described to you, that method is slow. It's limited to finding simple rules, and it can actually be inaccurate. Whereas this one is faster, it finds more complex rules, and it's more accurate. And what do I mean by that? Well, I always like to give this example. It's from a tweet, but someone was tweeting about, so Justin Trudeau was kind of sensitive in Chinese news at the time, and someone was testing for the word potato being censored on Weibo, because potato is one of the ways to refer to Justin Trudeau in Chinese. And they tested it, and in fact, it was censored. So like, oh, potato is censored on Weibo. There must be this political censorship targeting Justin Trudeau. But then we did the same test using this algorithm. We found, no, that's actually not what's happening at all. This word is being censored because it contains the word pot. And so this isn't political censorship at all. This is actually related to drugs. And so the conclusion that was being arrived here in this tweet was completely not the right one. And you know, this is a tweet, but you know, people encode this kind of logic in their research too. So you know, if you're doing this kind of testing, don't do this. You're going to get bad conclusions, bad results. So before, I assumed that we had a censorship oracle that would tell us whether something is censored or not. The way that this works in practice is a little bit more complicated, but here are some examples. So at the top, we have an example from Tencent Translate. You can see 3 sentences there, but the second one is missing. It says that Xi Jinping is the president of China. It's censored because it contains the word Xi Jinping. Most of the translation services that we looked at censor based on sentence or line. An example of that is another example though is on the bottom. We can see one from Microsoft Bing. It just censors the output completely. And note too, you know, I number these sentences, so it's obvious that censorship is happening. But if you were copying and pasting, you know, a page of text and one of the sentences was missing, and you couldn't read the output, you might not even know that that's happening. So as our test material that we used to try to infer rules, in past work we've used news articles and even done the testing as the news articles are being published in real time. In this case, unfortunately, we weren't able to get to that, but we did create 2 different test sets. One is what we call the people test set. This is just a bunch of names, over 18,000 names of people from Chinese Wikipedia. The other test set that we call the general test set, and this is just like the combined sum of all the different keywords that we've found censored on all sorts of different Chinese apps, a huge number of them. And just as a reminder too, like we're not testing these one by one, we're testing them like large chunks at a time. Using the algorithm that I alluded to earlier. So here's the results. Alibaba had the highest amount of censorship. Unfortunately, it also had the highest amount of bot detection, so we weren't able to complete the testing. But at least from the testing that we were able to complete, it did seem to have the most. The second highest was Youdao. Although, as we're about to see in a few slides, these numbers might be a little bit misleading for Youdao. We categorized the keywords that we found censored. I think the most notable thing on this slide is just that Bing only seems to censor one category of people, and that's the party leaders. You know, presumably to protect them from someone saying something negative about them. Whereas with the other ones, you can see more varied categories. And you can see something similar to that too when we're testing the general test set. Although there's more than one category for Bing, there's still fewer categories compared to the others. So yeah, so what I was alluding to earlier about Youdao, Youdao seemed to have something a little bit different in addition to just keyword-based censorship. It seemed to be using a machine learning-based approach as well. You can tell that these rules that we inferred using our algorithm, they don't really end on word boundaries, and for the most part, they're fairly like nonsensical. But some of the things that they have in common, or they have the names of political leaders, or at least coded references to them, and then usually some sort of insult or profanity or something like that. And so we think that there's some sort of machine learning filtering going on here. Um, and I think it's like still an open question as to how we can like best model this, like the way that like we're doing it on the slide might be a good enough way of capturing this kind of censorship. It might be a good way of trying to represent that, but I don't. Maybe there's a better way too. Yeah. So some of the practical implications of our work. Um, so Bing Translate did have one of the fewest numbers of rules, although its censorship was more extreme in that it censored the entire output as opposed to a single sentence. That could also be a good thing too, because the censorship is more obvious. And Bing also censored using fewer categories. But this is far from a foregone conclusion, though. In previous work looking at search engine censorship, we've seen Microsoft Bing also having fewer censorship rules, but rules that were much broader. And so they actually captured a lot more content compared to the Chinese search engines. Combining that with what we've seen looking at Apple censorship as well in the past, I think going forward, like our hypothesis shouldn't be to just assume that North American companies, when they're operating in China, have the least amount of censorship. It should be that they have the laziest amount of censorship. And in this case, that happens to be the least, but we've also seen in the past where Microsoft's censorship ends up capturing more due to the laziness. And we've seen that with Apple as well, where their laziness has also made their censorship overly broad. Just as a final reminder, this censorship does apply to a large user base outside of China as well. This doesn't just affect the users inside of China. But I think there's also another aspect to this as well, which is that even if you've never used any of the translators that I'm talking about, even if you've never used an online translator at all, you might still be a victim of the censorship and not even know it, because you've probably read something that was translated by one of these translators. And that could have happened, and that censorship could have happened secretly without the person using the translator knowing, as well as without you, the reader, knowing as well. So if you found this at all interesting, please read the paper. There's plenty more details in there. We also have all of our data available on GitHub, so if you're interested in that, please check it out. With that, thank you, and I look forward to your questions.
Thanks for the nice talk. I was unclear on how exactly the censorship is being applied. Is it being applied to translation from Chinese as an entire language, from people coming from certain areas? Are there ways that you can get these services to do Chinese translation that wouldn't be due to that censorship, maybe dialects or related languages?
Yeah, so for the Chinese-operated translators, they apply it to everyone. For Microsoft Bing, it applies to users with like IP addresses that they consider Chinese, using like a IP to geolocation lookup database. The rules also, of course, will be in some language. So the censorship rules will contain Chinese words or sometimes English or some other languages. We also saw Tibetan as well. So in that sense, if you're translating from German to Polish, if you're using Baidu, even though it's heavily censored, you might actually somehow evade the censorship if they haven't thought to like incorporate German or Polish censorship rules.
Yeah, that was my related question, which is, did you look at other languages, or were you focused specifically on Chinese? Did it matter what language you were translating into also?
So we didn't see the selected language. We didn't see that as a variable that that affected the censorship. But again, like just what language you're using is going to make it more or less likely whether you trigger these rules. And we didn't look specifically at any language, but in our test set, it was predominantly Chinese. There was English content, and there was content from other languages as well, such as Tibetan, actually German, French, Russian, but not as much. It's not nearly as represented.
Thanks.
We have one question from online.
Yeah, go ahead, Ian.
Great, thanks. So if the rules are triggered on words in a particular order, then when you started with your list of 500,000 words, how do you get them in the order that would trigger the rules? Like, there are way too many permutations.
Right. Yeah. So there's no guarantee that we'll find. It depends, I guess, what your expectations are. Like if your expectations are going in that you'll find every possible permutation from there, then that's not, that won't be possible. But as a second note, the most common kind of rule that we did see on these platforms was that they implemented unordered rules. So in practice, it's not much of a concern, but we just sort of model it as ordered, just to cover all of the cases.
I see. But so in your slide, you indicated you gave the first chunk of words as a thing to like the input to your algorithm, but then you'd miss any rules that had like one word from the first chunk and one word from a later chunk.
Right. Yeah. Absolutely. There's.
Okay.
I mean, to my knowledge, there's no feasible way to, capture every. When you have a data set of that size, to capture every permutation of every, of all those words that could possibly,
Right.
All
right. Thanks.
Mm-hmm.
Yes. One last question.
Okay, thank you. Bing also censors access to its websites and have been criticized heavily for this. One of their justifications for this is it's okay because they're careful to only block websites which are blocked in China, so they're providing a better experience through not showing websites in response to search queries which the user would not be able to see themselves. I don't know whether I believe that, but that's what they say. I don't think that justification works for this. So is there a plausible reason for doing this censorship that benefits the users? And has Microsoft said anything about why they're doing this?
I think that's a pretty dubious justification, even in the case of Bing search. So on top of what you're talking about, where they block sites that are blocked by the Great Firewall, they also have additional censorship on top of that, where they censor queries based on the content of those queries. And if that censorship is, if you have a query triggering that kind of censorship, you'll get responses from a handful of websites that have been basically pre-authorized that consist of state media and of government websites. So it's it's sort of along the same. It's similar to what we're seeing here in that that censorship is silent, and you might not even notice it's happening unless you're looking for it very carefully. But there's no justification for doing that that could possibly be said to protect the user, just as the kind that we're seeing here.